check the definition of a DC circuit. DC circuit is a circuit that controls the flow of electricity in one direction. DC is commonly found in many low voltage applications, especially in applications where the source of the power is the battery. In general terms, in order to create a circuit, we need the load, the batteries, the switch, and the wires. Short circuit. What is the meaning of a short circuit? If you remember in the first video, in the first picture, this is the positive side, the power coming in, and this is the return into the negative of the battery. If suddenly I connect one of these portions of the positive side directly to the negative, I produce a short to ground. If I connect any part of the positive side directly to the negative or ground, this is a short to ground. This is the definition that I have here. And now we are going to talk about the different type of circuits that we found in any electrical installation. We have series circuits, parallel circuits, and combined circuits. It's circuits that are configured in series and parallel together. We are going to study right now in details series circuits, parallel circuits, and combination of both of them, series parallel. Okay, we are going to start with a series circuit. Okay, this is a typical series circuit. We are going to refresh the picture. This is the battery. I have the positive terminal here, the fuse, the breaker on off or switch on off. After that, two loads. One load and the other one connected in series. Follow me. This is the positive. The positive enter in the bottom of the light bulb, and from the case of the light bulb, okay, we are going to solve it right now. One typical example of a series circuit. I prepared for yours this example. Suppose that we have a series circuit with three loads, three resistors. Resistor number 1, 5 ohms. Resistor number 2, 10 ohms. Resistor number 3, 15 ohms. And we are going to calculate all the values. We are going to calculate voltage, intensity, and resistance in each point, in point number 1, point number 2, point number 3. And we are going to calculate the three values, voltage, intensity, and resistance at the source of the power. Total voltage, total intensity, and total resistance. Okay, in this particular case, I know the total voltage and the total resistor 1, resistor 2, and resistor 3. I need know one intensity, because the first step is identify what is constant. In this particular case, because it's series, the intensity is constant. I need know the intensity in one point, and immediately I know the rest of the intensities. Okay, what intensity will be easy to find it? Probably the total intensity. But the only way to calculate the total intensity is if I know the total resistance. Okay, this is a parallel circuit. What is the advantage of a parallel circuit? The parallel circuit is a circuit in which the resistors are arranged with the heads together and the tails together. What is the meaning of that? You remember when you connect batteries in parallel? Positive with positive and negative with negative. Three batteries. Positive with positive with positive and negative with negative. Okay, they are in parallel. And you remember when you connect batteries in parallel, what element increase? The intensity, the amps increase in parallel. And what is constant? Is constant the voltage. Okay, it's exactly the same right now in the circuits. I have a circuit in parallel. I create that circuit for you, exactly the same. The input information is exactly the same like the previous one, 20 volts on the battery, and I have three resistors, 5 ohms, 10 ohms, and 15 ohms. Okay? Remember, in a parallel circuit, is constant the voltage. Is constant the voltage. What happened in this particular case? I know the total voltage, 20. Let me check the table. I know the total. Because I know the total, I know voltage 1, voltage 2, and voltage 3 because all of them are the same, 20 volts. So this is a typical combined circuit with this circuit in series with a parallel. The first resistor is in series with the resistor number 2 and resistor number 3. This is the diagram, and this is the schematic. You have the battery, resistor number 1, in parallel with those two resistors. Okay, I did these examples, and we are going to solve that example using the same values that I used in the previous circuit. Okay, I have a circuit with the total voltage 20 and resistor number 1 5, resistor number 2 10, and 15. And we are going to find the rest of the values. This is series and parallel. This is a series circuit. This is a series circuit. This is the switch, and I have two light bulbs. Okay, when I close the switch, immediately the lights are on. What happens if one of the lights is broken? What happens if one of the lights is broken? Here. Okay, right now the system is out. I don't have any lights. This is the inconvenience again. If I have a parallel circuit, if one of the elements is broken, the current continues for the other path. This is better. In that case, a good recommendation is install those bilge pumps in parallel, not in series.